Okay, so this video will hopefully help you to understand the empirical rule, or sometimes it's called the 68, 95, 99% rule. So there's already a video on the class YouTube playlist. It is video 1.8, part 2. And this video will hopefully help us understand questions like this from Khan Academy. So first, this visual here, you can see that this is a normal distribution. It is a symmetric bell-shaped curve, and you can see that from here to here is 34%. From here to here, since it's the same distance and it's symmetric, this is like the mean is found right here. This blue or light blue section here contains 68% of the values with a 1 standard deviation away. From this side to this side is 95%, and almost the whole thing is 100%, but it is 99.7. You have a little green section here, which is 0.15 and 0.15. This is what we're going to use to help us with the problem today. And this visual here is also on your on Schoology on the word wall folder. So this is a normal distribution. It is symmetric. The area under the curve is always exactly equal to 1 or 100%, depending how you want to look at it. And this is capital N means that we are looking at a normal distribution. The first number that you're going to see is the mean, and the second number is the standard deviation. Here's the question. And depending on what question you got, there's different variations on Khan Academy. I'm just going to answer this one and this one. There's two, but they're very similar. The lifespans of gorillas in a particular zoo are normally distributed. So now it tells you that you're allowed to use the normal distribution and the 68, 95, 99.7 rule. The average, this is your mean, is 20.8 years. The average gorilla lives 20.8 years. The standard deviation is 3.1 years. Okay, so then this is normally distributed, and the mean is 20.8, and the standard deviation is 3.1 years. Use the empirical rule to estimate the probability of a gorilla living between 11.5 and 27 years. Notice that I don't see any numbers here, so the first thing that I'm doing is I'm going to label my distribution here. In the middle, you find the mean. So in here, it is 20.8. Now, the first line is 1 standard deviation away, so then we use the 3.1. So let's do 20.8 plus 3.1. That should take us to the next value here, which is 23.9. Add 3.1 again for 2 standard deviations away. That should be 27, and then 30.1. Going backwards, take 20.8 and take away 1 standard deviation. Take away 1 standard deviation, do it again, and do it again. And that's how you get these 3 values. So 17.7, 14.6, 11.5. That looks, where's the eraser? Okay, now I'm looking for 11.5 and 27. So 11.5 is right here, which is the 3 standard deviations all the way to 27. So from here all the way to here. So that's going to be the majority, right? That's going to be a big number. So there's different ways to do it. You could add each portion. using these values. Actually, me. Okay. Or another way you could do it is, since 11.5 is 3 standard deviations away, which what we could do is, we already know that 3 standard deviations away contains 99.7. So that means from here all the way to here is 99.7. But really, I don't need this. I don't need this part. So I could subtract it. So I could take 99.7 minus this little section that I don't need, which is 2.35, right? I don't need, let me use a different color here. I don't need this section, so I'm going to subtract it. 2.35, you subtract those values, you'll get 97.35. So we have answered the first question. The probability that a gorilla living between 11.5 and 27 years, that's almost the whole curve. So it's 97.35. All right, next. Let's do it. Ah, I erased it. Oh, there we go. Let's do it again. There, I'm gonna keep the same values on the bottom. Okay, the second question says, use the empirical rule to estimate the probability of a gorilla living longer than 23.9 years. So 23.9 years is here. So we're interested in from 1 standard deviation and above. So we could add this part, and the little tail here. Okay, so remember the last 3 values. So add 0.15, which is this part, out of the 2.35, and out of the 13.5, and you should get about 16%. 16%.